about the z-axis, and y is the y distance measured from the centroid. Okay, so if we were to look at the units, this can be in Pascal. Now for this course, I'm going to work both units. Okay, Pascal or pounds per square inch. Okay, we are a land of immigrant, so welcome to Canada to do both. Okay, and pound inch. This one is in meter 4 or inch to power 4, and this is in meters or in inches. Okay, now question for you all: why negative? Anyone? Why is it that is negative? Why the formula put a negative sign over there, or we just accept the fact that's negative? Anyone? Can you all recall? What if when you are doing analysis and you forget that it's negative? What will happen? Anyone? If you forget that you have to put a negative sign in front, what will happen? You'll be in trouble, yes or no? Compression will be tension, tension will be compression. Or you always get compression or you always get tension, yes or no? Okay, now I'm going to explain to you physically, okay, why it's negative, okay? And it's not difficult, okay? So anyone, any questions so far? Anyone? Okay? Too early, huh? Wakey, okay? Okay, let me do a short joke for you guys. What do you guys call an exploding monkey? Anyone? Hello?
A mess to clean up.
No, an exploding monkey is called baboon. Oh my god. Good morning, a monkey. Okay, you guys are still awake. Okay, let's look at the deformation pattern. Yeah, let's look at the deformation pattern. Dead monkey. Okay, so if we look at the deformation pattern, okay, so I'm going to draw how the structure is deformed. Okay, this is how the structure is deformed, right? And then I'm going to sketch our centroid. Okay, so this is the centroid, and based on how the structure has been deformed, we know that the moment vector will be in this direction. Okay. And then it's a coupled moment. And then I'm going to call a point. This point over here is known as the center of curvature. Okay, that is the center of curvature. So I'm going to pick the center, point C. So this is our point C. Okay, why I pick point C? Okay, can anyone explain to me why? Sorry, not point C. I call this point B. Okay, and the top part is point B alpha. Below is point B beta. Okay. Now, can anyone tell me why I put point B? Why did I pick point B? Anyone, please. Why did we select point B? Why didn't we select point A and point C? Why are we focusing on point B? Anyone?
Because there's no vertical shift in A and C and only in B.
Yeah, so what if there's a vertical shift? Nelson, you're right. Or is it Jackson? You're right. Oh, yeah, Jackson.
Jackson, yeah.
Yeah. So you're right. So what if there's movement? What will happen?
It will bend down.
Yeah, you'll bend down. Okay. Why we pick point B now, Jason? Let me ask you: if this thing were to break, where will it break?
It'll break at point B.
There you go. You just did a failure analysis, right? Remember what I told you before, right? A critical thing about this topic is what? Failure analysis. You calculate where the most likely the structure will fail. If you're not sure, it's okay. You just need to do more calculation. Okay, if you're not sure, you just need to calculate more. Okay, so we know for the fact, and don't worry, okay, I will teach you how to identify them. Okay, I will teach you how to identify them. So we know that point B is the likely is where failure will occur. Where failure will occur is where, okay, where failure will occur is where maximum stress will occur. Okay, so no point calculating stresses from point A, between point A to point B, and no point calculating stresses from point B to point C. Just focus to point B. Okay. Okay. Right. Okay. So now the next thing is, again, I'm going to draw our transformation. Okay. So from the centroid, anything pointing towards the what? Towards the center of curvature, y is what? Positive. Okay. Any point away from the centroid, y is what? Negative. Okay. So based on this notation, right? Based on this notation, we can calculate stress x at point B alpha is equal to minus mz over izz. This is the easy part. Okay, izz. Now the y is what? Positive. Right? So at the end, when you multiply of them, you have minus mz over izz multiplied by what? Y. And it's a fact that B alpha, B alpha is in what? Compression. Right? So this is doing compression. Right? And then next we look at stress X B beta. So this was equal to minus mz over izz. Okay. Now the y is what? B beta, the y is what? Negative. So this will be equal to mz over izz multiplied by y. So we know that this is what? Positive. Okay. So negative means it's in compression. Positive means it's in tensile. Okay. So likewise, you can see over here, right? This end is in tensile. Okay. So that's why we have a negative sign. Okay. To make sure that the stresses are right. That's why we have a negative sign over here to make sure that the stresses are correct. But it's all dependent on the what? On your y, whether is it positive or negative. Let's do another short example. Okay, a very short one. What if now the bending go this way? Okay, now the bending go this way. Right? So this is still our point B. Right? Over here is our B, point B alpha. Then over here is our point B beta. Right? And then we know in order to induce bending in this direction, or the deformation in this direction, your moment has to be in this way. Okay, your moment has to be in that way. So now what you can see over here, right? Now you can construct your centroid. So this is our centroid, right? Over there is our centroid. Then we can see that here. Now this point over here becomes your center of curvature. Transformation did not change. Okay, x, y, rotation by z did not change. However, what changes this? Okay, so based on the center of curvature, anything going down here, y is what? Positive. And if it's pointing away from the center of curvature, y is what? Negative. Okay, so for this case, stress x at point B alpha is equal to minus mz over izz. Now your y is what? Negative. Right? Because point B alpha, the y direction relative from the centroid, okay, everything's relative from the centroid, is pointing away from the center of curvature. So this you get equal to positive mz over izz multiplied by y. Okay, so now you have stress x point B beta. So this will be equal to minus mz over izz. Now the y, right? Now the y is pointing towards the center of curvature, so it's positive y. So this is equal to mz, or this is minus mz over izz multiplied by y. Okay, so now it flipped. It becomes tensile over here, and then it become compression over here. Okay. Now I'm going to teach you an easier way to do this, without even remembering where is y positive, where is y negative. Also without remembering whether is it minus mz over izz or plus by mz over izz. The easiest way is this. Focus on the moment vector. What do I mean by that? Okay. The head of the arrow is always in what? Compression. The tail, okay, is always tensile. You just need to remember this, okay? The head is always in compression. The tail end is always in tensile. That's all you need to remember. No need to remember minus IMY. Okay. So that is where I want you all to what? Visualize. Okay, visualize the bending and not just, okay, let's throw everything in the formula. Okay, I'm going to stop the lecture here. Come back at 10:20. Okay, sorry, 10:30, and we carry on. Okay, thank you. I will still stay behind if you have any question. Okay.